All right, today we're going to tackle two types of math problems that can look, well, pretty confusing: quadratic and absolute value inequalities. But trust me, by the end of this, you're going to have a clear step-by-step plan that makes solving them a total breeze.
I mean, look at these. If you've ever seen an expression like this and your brain just kind of went, nope, you are definitely not alone. They can look super intimidating, for sure. But here's the secret. There's a simple logic behind them, and we're about to crack it wide open.
And that's really our goal today. We're going to translate this mathematical language into a simple, reliable method. By the time we're done here, you won't just understand these problems, you'll know exactly how to attack them with confidence, every single time.
Okay, first up, quadratic inequalities. The absolute key here is to have a consistent game plan. So let's walk through a four-step method that you can use on any quadratic inequality you come across. It's like your secret weapon. So, what's the big idea with these? Well, unlike a regular equation, where you're maybe looking for one or two specific answers for x, with inequalities, we're hunting for an entire range of numbers, all the possible x values that make the statement true. And here it is, our four-step roadmap. It's super simple. 1. Get everything on one side so it's compared to 0. 2. Find the boundary points by solving it like a normal equation. 3. Use those points to chop up a number line into test intervals. And 4. Test each of those intervals to find our final answer. Sound good? Let's put it into action.
All right, let's get our hands dirty with a classic example. We need to solve for x squared minus 4 is greater than 0. So we're looking for all the numbers x that make this statement true.
Okay, so step 1, making sure it's compared to 0, is already done for us. Easy. So we jump right to step 2, finding the boundary points. And to do that, we're just going to pretend for a second that this is an equation. So why do we do this? Well, think about it. The only way an expression can go from positive to negative or vice versa is by passing through 0. These points are our critical markers.
This one's a nice easy one to factor, right? It's a difference of squares, so it becomes x minus 2 times x plus 2 equals 0. And that gives us our two boundary points, x equals 2 and x equals negative 2. Seriously, think of these two numbers as the keys that are going to unlock this whole problem.
Okay, on to step 3. This is where those keys come in handy. Just picture a number line in your head. When we place negative 2 and positive 2 on that line, what happens? It splits the entire line into 3 distinct zones. We've got the part to the left of negative 2, the part between negative 2 and 2, and the part to the right of 2. Our answer has to be in at least one of these zones. We just have to figure out which ones work. And now for the final step, step 4. We test them out. You can see it all laid out in this table. All we have to do is pick one easy number from each of those 3 zones. So let's pick, say, negative 3, 0, and positive 3. When we plug each one back into our original expression, x squared minus 4, look what happens. For the outer zones, we get a positive number, which makes our inequality true. But for that middle zone, we get a negative number, which is false. That's exactly what we needed to find out.
So, the hard work is done. We just grabbed the intervals that worked, the ones that tested true. Our solution is everything from negative infinity up to negative 2, and also everything from positive 2 on up to positive infinity. And notice we're using parentheses here. That's because the original problem was strictly greater than, not greater than or equal to, so the boundary points themselves aren't included.
Awesome. So now we've got a totally solid method for quadratics. Let's switch gears and talk about absolute value inequalities. And here's the really good news. These almost always boil down to just 2 main patterns. If you can learn to spot the pattern, you've basically already solved the problem.
But first, just a super quick refresher. What even is absolute value? It's just a number's distance from 0 on the number line. That's it. And since you can't have a negative distance, the absolute value of something is always positive or 0. This one simple idea is the key to everything we're about to do.
And here they are, the only 2 patterns you really need to know. On the left, you've got the less than pattern. A great way to remember this is to think less than. It becomes an and statement, where the solution is sandwiched between 2 numbers. On the right, you have the greater than pattern. This one breaks into 2 separate or problems, where the solution shoots off in 2 opposite directions, away from the middle.
Okay, before we move on, let's just quickly cover a few essential tips. Honestly, these are the little things that'll help you dodge all the common traps and save you a ton of headaches.
First off, and this is a big one, always get the absolute value part by itself on one side of the inequality before you do anything else. Isolate it first. Second, that classic rule from algebra still applies. If you multiply or divide both sides by a negative number, you have to flip the inequality sign. And finally, pay attention to your notation. Use square brackets if the endpoint is included, for less than or equal to, and use parentheses if it's not.
And here's a special case, a huge trap a lot of people fall into. Just look at this and think for a second. Can an absolute value, which we know is a distance, ever be less than a negative number, like -5? No way. It's impossible. Distance can't be negative. So if you see this, you can stop right there. It's a trick question. The answer is no solution.
So, we've gone through the how to solve these problems. But what about the why? Like, why does any of this actually matter? Well, it turns out these concepts show up in a lot of real-world places, way beyond the textbook.
Take engineering, for instance. A part for a car engine might have to be a specific size, but there's always a tiny acceptable margin of error, a tolerance. That acceptable range is defined by an inequality. It's literally what ensures all the parts fit together and work the way they're supposed to. It's the same thing in science. When a scientist takes a measurement, it's never 100% perfect. There's always a little bit of uncertainty. They use inequalities to create something called the confidence interval, which is basically a range that tells us how reliable and accurate their results really are.
And you see it in business too. A company might use inequalities to figure out, hey, how many units do we need to sell to guarantee we make a profit? Or how can we make sure our costs stay below a certain budget? It's all about defining successful ranges.
Look, like with anything, getting good at this just comes down to practice. But here's maybe the most important tip I can give you. Always, always check your answer. Just grab a number from your solution range, plug it back into the original problem, and see if it works. It's the fastest way to know you got it right, and it's a huge confidence booster.
And that really brings us to the big picture here. What you're learning isn't just about solving for X. The real skill you're building is analytical thinking. You're training your brain to take a complicated-looking problem, break it down into logical, manageable steps, and follow that path to a correct answer. And that is a skill you will use absolutely everywhere in life.
So there you have it. We've translated the language, we've laid out the game plan. You now have this powerful set of tools for logical problem solving. So the only real question left is, what problems are you going to solve?